Okay guys, today we're going to utilize our factoring skills to solve by factoring. And all it means is that instead of having an equation that we factor to two binomial pairs, is that in this case we will now factor, the equation will be set equal to 0, and we will set each of those factors equal to 0. So we'll start with the first trinomial, 3u squared plus 24u minus 45 equals 0. So the only difference in what we did last week and what we're doing now is that equals 0. That's the only difference. Is now that we've added this equals 0, I have to solve for an actual value. I'm not just going to factor and get two answers. So in this case, the first thing I'm going to do is I'm going to notice that 3, 24, and 45 are all divisible by 3, and that the leading term is negative. And if the leading term is negative, I have to factor out a negative. So I'm going to factor out a negative 3, which will leave me with u squared minus 8u plus 15, which is all equal to 0. Then I'm going to use the same factoring process we've been using. I'm going to multiply the number a, the number in front of u squared, times c, which is the last number by itself, and a positive 1 times a positive 15 is a positive 15. Then I'm going to take the factors of 15. That's going to be 1 and 15 and 3 and 5. Because it's a positive, that tells me I have a positive times a positive or a negative times a negative. Because my middle term is negative, that tells me I'm going to use the negative factors. So I'm going to make all my factors negative. Then I'm going to add out to the right. Negative 1 minus 15 is negative 16. And negative 3 minus 5 is negative 8. Those are the ones I'm going to use because negative 8 is my middle term. I'm going to bring down my negative 3 to the next step. In this case, I notice that my leading term a is 1. So this is that special case that we talked about where we don't actually have to go through the process of factoring. We can go immediately to the answer because a is 1. Well, to get u squared, I have to multiply u times u. And then we've identified that our factors that we're going to use are a negative 3 and a negative 5. Okay? Negative 3 times negative 5 is a positive 15, and negative 3 plus negative 5 is a negative 8. So now that I have my factors, when we were factoring before, we would stop here. We would be done. That'd be your answer. But in this case, now that it says equals to 0, we have to use the zero product property, which simply states that if you have factors that are being multiplied together, anything at all, if you had like a times b times c, m times n times z, any numbers being multiplied together, if they are set equal to 0, at least one of those numbers has to be 0. So if I had a times b times c and it said equals 0, then either a, b, or c is 0 at the minimum. So I'm going to take each of these terms and I have to show that each of these could potentially equal 0. So I will set each individual factor equal to 0. When I set negative 3 equal to 0, that doesn't make any sense because negative 3 can't equal 0. So I showed that it does not equals and I'm done. I ignore that. It doesn't make any sense for this problem. But here I have u minus 3 equals 0. And if I add 3 to both sides, I get u equals 3. Then I have u minus 5 equals 0. And if I add 5 to both sides, I get u equals 5. These are your two answers. These are the zeros of your function. These are your solutions. These are your x-intercepts. These are your roots. So we talked about this earlier, how there were 4 words that mean the same thing. They're solutions, zeros, x-intercepts, and roots. These are them. Now, I do realize we're not using x as the variable, we're using u, but it's the same rule. It's just like as though that variable was x and we had an x squared problem. If I was graphing this, these are the 2 points where my quadratic function, my u, will cross the x-axis, okay? And this step is actually the zero product property when I went from this step and showed them each equal to 0. So then we'll do another example of that, example 2. This time it says 0 equals s cubed minus 9s squared plus 18s. The only difference in this example and this one is that they put the 0 at the end here and they put it at the front here. So a lot of times what you'll get is you'll get a function like f of x equals x squared, and they'll say find the roots, find the solutions, find the x-intercepts, find the zeros. Well, all you have to do is say 0 equals that function, okay? So that's why we're showing you an example with 0 in front. It's going to be the same process we've been using. So first thing I'm going to do is I'm going to see if I have a greatest common factor, and I'm going to factor it out. In this case, I have s cubed, s squared, and s, so I can pull out an s. And that leaves me with s squared minus 9s plus 18. Then I'm going to multiply a times c, so positive 1 times a positive 18 is a positive 18. If I take the factors of 18, I have 1 times 18, 2 times 9, and 3 times 6. Because it's a positive, it's either going to be a positive times a positive or a negative times a negative. Because my middle term is negative, it's going to be the negative, so I'm going to make all my factors negative. Then I add up out to the right and I get negative 19, negative 11, and negative 9. So we found that 3 and 6 will be the ones we're going to use. Come back to the original function, 0 equals s brackets. And I already know that a is 1, so I can go straight to my answer. I'll have s for the first step because s times s is s squared. Then we've identified a negative 3 and a negative 6 as our factors. Now this time when I set it equal to 0, I'll have 0 equals s, 0 equals s minus 3, and 0 equals s minus 6. Well, 0 equals s is not like negative 3 equals 0. This didn't make sense, but this does. This says that one of my factors is 0. That's one of my answers. Here, if I add 3 to both sides, I'll get 3 equals s. And there's my next factor. And then if I add 6 to both sides, I get 6 equals s. So in this case, you have 3 points where it crosses the x-axis. That's because this started out as a cubic, and a cubic will touch it more than once. But it doesn't matter for this. This will be a factor. All that matters for you is that if you have 0 equals your variable, that is one of your factors. You need to box that answer, okay? So these are your solutions, your zeros, your x-intercepts, and your roots. Then we're going to do 2 special case examples. The first one is 16b squared minus 40b plus 25 equals 0. I noticed that I could take the square root of the first term because it's a perfect square, and I could take the square root of the last term because it's a perfect square. So I need to check to see if I take the square root of the first term and the square root of the last term and multiply by 2, will it give me this middle term? So I'm going to go ahead and take the square root of the first term, and the square root of 16b squared is going to be 4b. Then I'm going to take the square root of the last term, which is 25, and I get 5. And if I multiply those two things times 2, 2 times 4b times 5, will it give me 40? Well, 2 times 4 is 8, and I have 8b. 8b times 5 is indeed 40. So this is a perfect square trinomial, PST, perfect square trinomial. I can go straight to my answer. I know that it's going to look like this. The sign in the middle is going to come from the sign on the middle term. And in the front goes the square root of the first term, which will be 4b. And the back will go the square root of the last term, which is 5. And this is completely factored. Now this actually means 4b minus 5 times 4b minus 5. Well, instead of showing 2 sets of work for the same thing, because you're going to get the same answer, it's going to be the same binomial, I only have to show it once. So I'll say 4b minus 5 equals 0. If I add 5 to both sides, I get 4b equals 5. And if I divide by 4 on both sides, I get b equals 5/4. And that is your 0. It actually, this quadratic function touches the x-axis one time at 5/4, which is like saying 1 1/4. Okay? Now, what I actually did when I went from this step to this step is I took the square root of both sides. That's one of the methods that we're going to use to solve quadratics later on. For this case, don't worry about it. You just know that if you have a perfect square trinomial, you only have to show one set of work at the end. Okay? Then example 4 is our last example. It's 0 equals 16n squared minus 9. It doesn't have 3 terms. The first thing I'm going to check is it a difference of 2 squares? The way I check that is, can I take the square root of the first term? Which in this case I absolutely can. 16n squared, if I take the square root, will be 4n. And then I check to see if I can take the square root of the last term. And the square root of 9 is 3, so I can do that. And then I check to see if there's a negative sign in the middle. If there is, this is a difference of 2 squares, which I usually abbreviate to D of S, difference of squares. Okay? And the way you write your answer for a difference of squares will always be 2 binomials. One will be positive and one will be negative. The square root of the first term goes in the front of both, and the square root of the last term goes in the back of both. And that's how you factor a difference of two squares. Now, since it's set equal to 0, I have to apply the zero product property. And I say 0 equals 4n plus 3, and 0 equals 4n minus 3. Okay? Now, when I'm solving, here I'll subtract 3 from both sides, and I get negative 3 equals 4n. Then I divide both sides by 4, and I get n equals negative 3/4. And there's your first 0. Then on this side, I'll add 3 to both sides, and I get 3 equals 4n. Then divide both sides by 4, and I get a positive 3/4 for n. And those are the zeros of your function. I do want to mention, and I want you to notice that for every single step after the original problem, I write that equals 0 until I solve for my answer. So equals 0, and then I set them each equal to 0. And if you look back up here at the top, I did the same thing. Started with equals 0, and then I split it out so they all equal 0. Same thing up here. Equals 0, and then split out so they all equal 0. You have to do that with every step. If you don't show me in every single step the 0 equals, it's wrong. So please make sure you add these to page 17 in your notes, and we'll work on our assignment on Monday.